Hey everyone, it's Amir Ali. Welcome to Code and Cadet by Sam. Hey, today we're diving into a super important concept, the Choreography Saga design pattern in microservices. And trust me, this is one of the most asked topics in microservices interviews. If you're preparing for microservices interview, you're in the right place. We'll keep it simple, straight to the point, and of course in our easy to digest style. Then we'll zoom in on the choreography design pattern, how it works, how the services talk to each other, and of course what happens when everything goes smoothly and when things go wrong. After that, I'll share some popular tools and frameworks that make this pattern easier to implement. And finally, we'll wrap up with the real benefits of using choreography and when it's actually the smarter choice in your system design. So let's get into it. Alright, so first let's understand what's a saga. Think of it like this. It's just a bunch of small transactions happening across different services. Each service updates its own database, then hands the work over to the next guy, either by sending an event or making a call. Now here's the cool part. If something goes wrong in any service, and see, in microservices, every service has got its own database. So if one service goes down or messes up, there's no big global transaction to keep things in sync. That's exactly where the Saga design pattern shines. It makes sure things either finish all the way or get rolled back nice and clean, even if the whole thing trips in the middle. So the Saga design pattern mainly comes in two flavors: orchestration and choreography. In orchestration, you've got a central brain, a controller service that tells each microservice exactly what to do and when to do it, kind of like a conductor leading an orchestra. Choreography, on the other hand, is fully decentralized. No boss, no central brain. Each service just listens to events and reacts on its own. Smooth coordination all through events. In this video, we are going to focus on the choreography side of things. We'll deep dive to really understand how it works, but for now, just keep that note in your mind. The choreography design pattern is all about microservices working together by listening and reacting to events without any central controller. Each service jumps into action when it gets the right event, so everything runs in a fully decentralized way. No single service is the boss here. Services just talk to each other through events. This is what we call event-driven. Services simply respond to the events they receive. It's like a dance where everyone knows their moves just by watching the signals, not waiting for someone to shout instructions. First, let's understand the happy flow of the choreography design pattern. Once we get this, we'll move on and see what happens if a service fails and how choreography handles it. So here's how the happy flow works. First, the client sends a request to place an order. Then this request lands in the choreography layer. You can think of this as our event bus or message router, which is purely event driven. After that, the choreography publishes an event to the order service. The order service creates the order in its own local database and then emits an order created success event. Next, once that event is out, the choreography sends it along to the payment service. The payment service processes the payment, updates its records in database, and emits a payment successful event. After that, the choreography pushes an event to the inventory service. The inventory service reserves the stock, confirms it, and emits a stock reserved event. Finally, when all these success events have been received, the choreography sends a final success response back to the client telling them your order is placed successfully. This entire flow is asynchronous and event driven, so services don't directly talk each other around, they just listen for events and act. And because of that, they stay loosely coupled and can scale independently. Now have a look at the failure case. What if the inventory service fails? How does choreography handle it? Let's walk through it step by step. Just like before, the client kicks things off by sending a request to place an order. Choreography passes this to the order service, which creates the order and emits an order created success event. That event then triggers the payment service. It processes the payment and emits a payment successful event. Now the inventory service gets the event to reserve stock, but this time it fails. Maybe the stock's out or there's some other issue. The inventory service emits a stock reservation failed event back into the choreography. Choreography now kicks in the compensating transactions. It sends a refund payment event to the payment service. It sends an order cancel event to the order service. Each service handles its rollback independently. Payment gets refunded, order gets cancelled. Finally, the choreography sends a failure response to the client saying, "Sorry, your order couldn't be placed." So even though we started on the happy path, a failure at any step is handled smoothly, keeping data consistent across all services. Alright, now let's quickly talk about the tools you can use for a choreography based saga. For this kind of event run magic, you need a message broker. Think of it like the postman that delivers events between services. Some popular ones are Apache Kafka, super powerful, great for handling a ton of events and real-time streaming. RabbitMQ, simple, reliable and perfect if you want easy to manage queues. Amazon SNS SQS, fully managed by AWS, so you don't have to worry about setup, just plug and play. These brokers make sure all your events get delivered to the right service at the right time, so the choreography dance stays smooth. Before we break down the key advantages of using the choreography design pattern, I'm requesting you, please subscribe to this channel and do support. Your support really helps me keep making more of these tech breakdowns for you. Alright, now let's get into it. First, decentralized control. No boss service here. Every service runs its own logic and decides what to do when it gets an event. Next, event run communication. Services talk by sending and listening to events, not by making direct calls. Then we have loose coupling. Services don't even know each other's names, they only care about the events they subscribe to. Highly scalable. You can scale up one service without touching the others. Super flexible. Improved service autonomy. Each service owns its code, its logic, and can be deployed whenever it wants. No need to wait for others. And finally, asynchronous communication. Services do their work without waiting for replies, so the whole flow stays non-blocking and scalable. Basically, everyone dances to their own beat, but the music is always in sync. Alright, so when should you actually use the choreography design pattern in microservices? You go for it when your services need to be truly independent and autonomous, meaning each service just does its own job without waiting for anyone to boss it around. It's a perfect match for event-driven workflows, as long as they are not too complex to manage. And here's the big win. It shines in systems that need high scalability and flexibility, because there's no central controller slowing things down. So yeah, overall this pattern helps you build a loosely coupled, highly responsive system where services can dance together without stepping on each other's toes. I hope you now have full clarity on what choreography is and how it actually works. If you like this video, please give it a thumbs up and don't forget to subscribe to this channel. Your little support really helps me grow here. And hey, press that bell icon too, because I'm going to cover all Java interview question topics from basic to advanced level. Thanks for watching. Then see you in the next video. Bye bye and keep learning.